An observer standing on a deck of a ship just sees a lighthouse top with his eye at a height of 9 meters. The top of the lighthouse is 64 meters above the MSL. What is the distance of the observer from the lighthouse? So we can represent the total question in terms of the figure. Then we will get here the observer row, 64 meters. If it is say B, it is A, 9 meters. So we have to find out AB. AB we have to find out. We know the correction. We will say D1 up to here and D2 up to here. First we know D1 by using the correction with the radius of the earth. D1 is equal to 3.853 root C1. Here C1 is 9 meters. By substituting C1 9 meters, we will get the value as 11.56 kilometers. The value will come in terms of kilometers. D2 is equal to similarly 3.853 root C2. C2 is 64. That implies the value is going to be 30.83 kilometers. We have to find out AB. AB is equal to D1 plus D2, that is equal to 11.56 plus 30.83, that implies 42.39 kilometers is the answer. 42.39, option C is correct. Question, we have to find out the effective stress at 1 meter below the ground level. So we have to find out the effective stress at this level. We know effective stress is equal to total stress minus pore water pressure. There is no water table at ground level, so pore water pressure is going to be 0. So only the total stress we have to calculate. And in the data that was given above, the saturating coefficient is 0.4. S is 0.4. We have to find out the gamma saturated at 1 meter below the ground level. Gamma saturated is equal to G plus ESR into gamma W by 1 plus E, where G is the specific gravity. We know the specific gravity 2.65 plus E is void ratio, we know 0.4, and saturation coefficient SR is given as 0.4 into gamma W, it was given it as 10. 1 plus E is 0.4. So gamma saturation is going to be 20 kilonewton per cubic meter. We know we have to find out the stress at this 1 meter below the ground level. Stress is nothing but gamma into height. We have to find out at 1 meter below, so height is equal to 1. So total stress is equal to gamma saturation into height. Gamma saturation is 20 into 1, that is equal to 20 kilonewton per square meter. Here the total stress is equal to effective stress. So total stress or effective stress that is sigma prime we can represent, that is equal to 20 kilonewton per square meter. So option B is correct. To find out the effective stress at 6 meter below the ground level. 6 meter below the ground level, the effective stress at 6 meter below the ground level we have to find out is total stress at 6 meter below the ground level minus pore water pressure at 6 meter below the ground level. First we will find out the total stress. For the total stress, we have to know gamma saturation into height. Height we know 6 meters. But here we have to find out the gamma saturation. We know up to 1 meter depth, up to 1 meter, we know the gamma saturation is equal to 20 kilonewton per cubic meter from the previous question. And below water table, gamma saturation is equal to G plus ESR into gamma W by 1 plus E. SR is going to be 0 because it is fully saturated below the water table. So G is 2.65 plus 0.4 divided by 1 plus 0.4 into 10. That implies 21.78 kilonewton per cubic meter below the water table, the gamma saturation. Therefore, total stress, we can calculate it as 20 into 1 plus 2 into 21.8 plus 3 into 20. At clay layer, the gamma saturation given as 20 at clay layer. So total stress is equal to 123.56 kilonewton per square meter. And pour water pressure, pour water pressure is equal to gamma W into H, that is equal to 10 into H is 5 meter. Below the water table, the pour water pressure is going to be, and above the water table it is going to be 0. So 50 kilonewton per square meter. So the effective stress sigma prime is equal to total stress sigma minus mu, that is equal to 123.56 minus 50, that implies 73.56 kilonewton per square meter is the effective stress below the 6 meter as shown in the figure. So option D is correct. Question: the two cars are approaching each other on a highway at a speed of 90 kmph. Car 1 speed V1 is equal to 90 kmph, that is equal to 25 meters per second, and car 2 speed V2 is equal to 60 kmph, and T is given as 2.5 seconds. Coefficient of friction is 0.7 and brake efficiency is 50% in each case. Coefficient of friction is given as 0.7 and efficiency is given as 50%. So friction efficiency is going to be 0.7 into 0.5, that is equal to 0.35. So what is the question? What is the stopping sight distance of a first car? Stopping sight distance of first car is equal to Vt plus V square by 2gf. That implies V is 25 kmph, T is 2.5 plus 25 square by 2 into 9.81 into 0.35. That implies 153.5 meters is the stopping sight distance for car 1. That is option A is correct. In this question, similar to the above problem, we have to find out the stopping sight distance for the second car. Stopping sight distance for the second car is equal to V velocity of the second car into T plus V square by 2gf. Here V is 60 kmph, that is 16.66 meters per second. So by substituting this V, we will get 2.5 plus 16.66 square by 2 into 9.81 into 0.35. That implies 82.2 meters is the stopping side distance of the second car. So option B is correct.